Here is the solution for the day 3 Bauer. What is the maximum value of the expression 7 times x plus 2 times y given these constraints on the values of x and y? First, x must be greater than or equal to 0. X can't be a negative. Y must be greater than or equal to 0. It cannot be a negative number either. And then this last constraint also must be true. Well, it's pretty easy to see what the minimum value of this expression would turn out to be if you use the smallest allowed x value of 0 and the smallest allowed y value of 0 and plug them in there. This would turn out to be 0. That's the minimum value. But we want to know what's the maximum value. To find this, let's use the linear programming theorem, which states the maximum value of an expression that involves x and y is found by using numbers for x and y that are located at a vertex of the enclosed region when graphing the constraints. So what we need to do is we need to graph this system of inequalities to create a triangle shape and then find the vertices of that triangle and use those x and y values into this expression to see which one ends up being the maximum value. So the first inequality is a vertical line just tracing along the y-axis. The second inequality is a horizontal line that just traces over the x-axis. Now let's do our diagonal line. This is in standard form, and while I could rearrange it to get the letter y alone, creating slope-intercept form, you don't have to. You can graph straight from standard form using intercepts method. When this term is 0, then x has to be 4. So there is a dot at positive 4 on the x-axis. That's called the x-intercept. When the x term is 0, the y is 8, because 0.5 times 8 makes 4. And so there's a dot at 8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8 up here. And then we can draw our diagonal line connecting these dots. Being greater than the vertical line, being greater than the horizontal line, but being less than the diagonal line is this triangular region of space. But what we're really interested in are the vertices. The bottom left corner is 0, 0. That would be the x and y values that would give us the minimum value of that expression. This dot right here is 4, 0. And this dot right here is 0, 8. Which of these ordered pairs, when substituted into the expression, creates the maximum value? Let's try the 0, 8. 7 times 0 plus 2 times 8 is 16. Let's also try the 4, 0. 7 times 4 plus 2 times 0. That makes 28. So what is the maximum value? It's 28.